D2. So you are going for D2. We'll do for both strong field and weak field. Okay. Okay. Now for strong field, the splitting will be more. Okay. So for D2, 1, 1. So this is T2G and this is DG. Okay. So now we know that electrons are always filled from the lower energy state. So it will be this. So what is the electronic configuration? Electronic configuration is T2G2 EG0. This is for strong field ligand. Okay. For weak field, the splitting will be small. Okay. This is electronic zero. Draw. And after that, you please draw D3. Once you practice, then you will not forget.
Yes, sir.
Okay, now see here. Now we'll go for, we have found both for strong field ligand and weak field ligand, D1, D2, and D3. They are all these electrons, they come to the lower equal energy level. Electronic configuration is same. Only the crystal field splitting energy is different. See here, here energy is less and here energy is more. Now I shall go for D4. Okay. So I'll go for now D4. See, 1, 2, 3, 4. Okay. Now 1, 2, 3, 4. See, out of these 4 electrons, so initially it will come here. 1, 2, 3. Now what will happen to the 4th electron? Here the energy gap is more. As the energy gap is more, in that case we will find the 4th electron will go for pairing. The electronic configuration will be here. Crystal field splitting energy is more. Due to that, the 4th electron will go for pairing. But when we go for the Widthfield Ligand, please write there. I forgot to write. So now when we go for Widthfield Ligand, see here. In this case, it's very interesting. So 1, 2, 3, 4 will come here, and as the gap is very less, the 4th electron will come here. So this from D4 onwards, you'll find the electronic distribution is different. See now here. It is T2, G3, EG1. Draw it. Please draw D5. Then we'll discuss some theory. Arrangement of electrons. Electron field ligand. The strong field ligands such as carbon monoxide, cyanide, ethylene diamine, ammonia, etc. cause large splitting of d orbitals. Therefore, the values of delta O. What is delta O? Crystal field splitting energy of octahedral complexes, octahedral complexes is greater than that of pairing energy. Pairing energy means where they undergo pairing. Okay, whenever the pairing occurs, energy is released. Pairing energy. Pairing energy P. That is delta O greater than P. Thus, the electrons prefer to get paired up in lower T2G orbitals. Now, when they pair up, the number of the unpaired electrons are less. So this results in low spin complexes. Okay, so we'll write now here. Thus, this results in low spin complexes. So what we can write? Therefore, strong field ligands form low spin complexes. Right. Crystal field theory is very easy. Widthfield ligands. বলো এই কত লিটার আইতো দুমদুম হয়ে গেটের মধ্যে মারে আর কে প্লাম্বার না না water oxalate hydroxide halide, etc. Cause very small splitting of the orbitals. Therefore, the value of delta O. Now you know what is called delta O, so I'm not writing. Anyway, I'll write from here. This you can write in short form also. Huh? This is accepted form, CFSC, crystal field splitting energy. Is small and much lesser than pairing energy, that is delta O. Therefore, in these cases, electrons prefer to go to higher energy, e.g. orbitals, instead of pairing in lower T2G orbitals. Thus, they form high speed complexes. So what is the conclusion? Conclusion is Widthfield ligands form high speed complexes.
Excuse me, sir. Excuse me, sir.
Hello.
So, after that, less than, is it pouring energy?
Pairing.
Okay, sir. Thanks, sir.
No, sir.
This is a theory. You know. You have to go for application. That you can do it very nice. This question often comes in both the CBSE and the MBOS sector. Now, how to remember this one? How to remember this? See here. Only you remember this. This is enough. This word is sufficient to explain the crystal field theory. Slow. See here. I'll break it into two parts. What is it? S stands for strong field ligand. And what is this? Low spin complexes. This is the whole theory that you have learned in 3 days. This is your secret. You don't tell others. Okay? Now, question. Prove that Fe CN6 3 minus is a low spin complex, while Fe F6 3 minus is a high spin complex with the help of crystal. See, then I'll write it in short form CFT. So I'm just giving you in how to do it. First, you find the oxidation number of the iron. Then you write down its electronic configuration. Then after that, you draw this crystal field splitting. Then put the electron and put it. I'll not do it. Do for both. And it is very easy. I give you you finish it, then I'll do it too. Then you can check whether you are correct or not.
Finish it. I finish it, sir.
Finish.
Yes,
And then
sir.
what about others? Ayushman Bhaya? Ayushman? That Aditi? Aditi, are you there? Bipasha? Eugenia? Deti? Daniel? CN6. what is the oxidation state? State of iron, you know it is +3. Then, what is the electronic configuration? আমি আমি তো মালবাহী খালি একটাই হয়েছে ওই বুঝে গেছি is what? Air 3D5 4H0. Okay, now should be always higher than this, huh? Please remember. Okay, now in exam, what you should be, you cannot write like this. You write here d orbitals of free Ap3 plus I. 1, 3, 5, 2, 3, 4, 5. Then we write here d orbitals in spherically symmetrical crystal field. 1, 2, 3, 4, 5. This is T2G, this is EG. From here to here, you write here delta O. What is delta O? Okay, now see here. This is a strong field ligand. So 1, 2, 3. Then other two also will go for pairing up. Why? Because this. So this proves, see, it is only one unpaired electron. This proves that it is a low spin complex. So what is the electronic configuration? It is evident from the electronic configuration of chain 6 that it has. So please correct it. So here Fe F6 3 minus. Up to this much is same. See, please remember, fluoride is a Widthfield ligand. So what will happen? Splitting will be less. So what will be the electronic configuration here? Here what you find here? Delta O is less than P. So it will be, see, 1, 2, 3. Then the fourth and this electron will go here. Early electron configuration, I made a mistake though. Please correct. You also don't say that, sir, you have written wrong. Hopeless people. This is the earlier one. Our present one is what? See here. 3. This is 2. That it has 5 unpaired electrons. And so it is a high-speed complex. You should be able to write it. এটা সব করতেই হবে সব কুকুরে বলে এটা কুকুর জাতীয় যত প্রাণী prove that See here. In what is the oxidation state of here? Iron is what?
2.
Very good. Electron configuration.
Yeah.
T2G6EG0.
So it is this. 6 electrons are there. This. Okay. So it will come here. 1, 2, 3, 4, 5, 6. What is here? What do you find here? D0 is more than P. So what will be the electronic configuration here? 6, 0. So what you will write here? Bye.